Hello everyone. Today I will be talking about nuclear chemistry. Now, nuclear chemistry is all about a search for stability. That means that if say a neutron is a element is not stable, it will attempt to create more stable isotopes of itself until stability is reached. They form these isotopes, the elements, by having the nucleus lose energy, called radioactivity, or radioactive decay, or nuclear decay. There's a lot of words to describe it. Now, when one half of a decaying sample decays, it's known as a half-life. Now, there's three types of radioactive decay: alpha decay, beta decay, and gamma decay. Alpha decay is pretty harmless. It emits what's basically a helium nucleus when it's decaying. It can be stopped by something like a piece of paper or cloven. Now, next you have beta decay. Beta decay has a little bit more energy than alpha, and when it decays, it emits electrons. It can be stopped by something like aluminum foil. And then last but not least, you have gamma decay. This stuff is the real dangerous stuff. It's like what they always have whenever a nuke detonates. You know how the gamma radiation turned Hulk into Bruce Banner into the Incredible Hulk. It's very dangerous. It can go through anything but lead, which is why they put radioactive samples in lead containers. Now, the energy needed to remove nucleons, which are what make up a nucleus, protons and neutrons, the energy needed to remove nucleons from a nucleus is called binding energy. And it is represented by E equals mc squared. And if you haven't heard about that, you're living under a rock. Basically, it means energy equals mass times the speed of light squared. It says that energy and mass are interchangeable. Now, what keeps the nucleons in the nucleus is the mass defect. Wait, hold on. The mass defect, which is made out of energy. It is m in E equals mc squared. If you were to use E equals mc squared to try and figure out how much energy a decaying atom creates, you would find out that that's a lot of energy. Now, there are two ways that we know of, and I mean humans, to create this energy. Fission and fusion. In fission, you split a nucleus in two by sending a neutron into a target nucleus, which then creates fission product. And in fusion, you get two nucleuses. In this case, I believe they're hydrogen isotopes, helium isotopes, but basically you cause them to combine with each other, and then that creates a lot of energy. In fact, fusion creates like a lot more energy than fission, and that's why us as humans really want to understand it. Because while we understand fission a lot, and that's what we use in like the nuclear power plants, we haven't been able to safely contain fusion. An example of like a fusion reaction is Hiroshima and Nagasaki. Well, that's everything I have. So I hope you were paying attention, and I hope that I'm understandable because the quiz is going to be coming next.